Measure of dispersion for ungrouped data. KSSM Mathematics Form 4. Effect on data changes on dispersion. Example 13, page 228 to 233. What is the effect of data changes on dispersion? The data changes include the following cases. A. Each data is added or subtracted by the constant uniformly. B. Each data is multiplied or divided by the constant uniformly. C. The existence of outliers or extreme values in the set of data. D. Certain values are removed from the set of data or added into the set of data. What are the effects on the measures of dispersion when each data is changed by adding or subtracting a constant? Consider this case. Initially, have a set of data 5, 8, 3, 4, and 1. If each value of the set of data is added by 5, then the data above will be changed to 10, 13, 8, 9, and 6. What will happen to the measure of dispersion such as range, interquartile range, variance, and standard deviation from the new set of data? Firstly, sort the data from small to big. Then the range is equal to the maximum value minus the minimum value. 8 minus 1 equal to 7. The quartile range is equal to the third quartile minus the first quartile. Before that, you need to find the median. Median is the middle of the whole data, that is 4. After that, you need to find the third quartile. 4 is the median. After median, there are two data. Third quartile is in the middle of these two data, that is 5 plus 8 per 2 equal to 6.5. Then we need to find the first quartile. Before the median, there are two data. The first quartile is in the middle of these two data, that is 3 plus 1 per 2 equal to 2. So interquartile range equal to 6.5 minus 2 equal to 4.5. In order to find variance, we need to find mean. Mean is equal to the average of the data, equal to 4.2. Variance is equal to, we square all these numbers and add all of them, 10 per 5, minus the mean square, equal to 5.36. Standard deviation is equal to the square root of variance, that is square root of 5.36 equal to 2.3152. Then each value of the set of data is added by 5. Become 10, 13, 8, 9, and 6. Then we sort this from small to big. Then we find the range is equal to 13 minus 6 equal to 7. The quartile range is equal to 11.5 minus 7 equal to 4.5. Mean is equal to the average of the data, that is 9.2. Variance is equal to 5.36. And standard deviation equal to square root of 5.36 equal to 2.3152. So range, interquartile range, variance, and standard deviation for these two sets of data are same, only mean is different. So there are no changes to the measure of dispersion when each value of a set of data is added or subtracted by a constant. Mean is not a measure of dispersion as it cannot show the dispersion of data. Is subtracted by a constant k equal to is added by a constant negative k. What are the effects on the measure of dispersion when each value of the set of data is multiplied by a constant? Consider this case. Initially, have a set of data 5, 8, 3, 4, 1. If each value of the set of data is multiplied by 2, then the data above will be 10, 16, 6, 8, 2. What will happen to the measure of dispersion such as range, interquartile range, variance, and standard deviation for the new set of data? For this set of data, the range, the quota range, mean, variance, and standard deviation are same as previous. Then each value of set of data is multiplied by 2. Come 10, 16, 6, 8, and 2. Then sort the data from small to big. And range equal to maximum value minus the minimum value, 16 minus 2 equal to 14. In the quota range equal to the third quartile minus first quartile. Like previous, the third quartile is in the middle of these two data. 10 plus 16 per 2 equal to 13, and the first quartile is in the middle of these two data. 6 plus 2 per 2 equal to 4, so in the quota range equal to 13 minus 4 equal to 9. Mean is equal to the average of the data, equal to 8.4. Variance is equal to square all of the data and add all of them per 5 minus mean square equal to 21.44. Standard deviation equal to the square root of variance, mean square root of 21.44 equal to 4.6303. We found that the range 7 multiplied by 2 equals 14. Then in the quota range, 4.5 multiplied by 2 equals 9. And then the mean 4.2 multiplied by 2 equals 8.4. And then the variance 5.36 multiplied by 2 square equals 21.44. And finally, the standard deviation 2.3152 multiplied by 2 equals 4.6303. In conclusion, when each value of the set of data is multiplied by the constant k, then new range equals k multiplied by original range. New in the quota range equals k multiplied by original in the quota range. New standard deviation equals k multiplied by original standard deviation. And the new variance equals k squared multiplied by original variance. What are the effects on the measure of dispersion when each value of the set of data is divided by a constant? Consider this case. Initially, have the set of data 58341. If each value of the set of data is divided by 2, then the data above will be 2.5, 4, 1.5, 2, and 0.5. What will happen to the measure of dispersion such as range, in the quota range, variance, and standard deviation for the new set of data? So for this set of data, the answer is just like previous. So each value of set of data is divided by 2. Come 2.5, 4, 1.5, 2, and 0.5. And then we sort them from small to big. So the range equal to 4 minus 0.5 equal to 3.5. In the quota range, it's equal to the third quartile minus first quartile. The third quartile is in the middle of these two data. 2.5 plus 4 per 2 equal to 3.25 minus the first quartile. The first quartile is in the middle of these two data. 0.5 plus 1.5 per 2 equal to 1. So in the quota range equal to 2.25. Means equal to the average of the data equal to 2.1. Variance equal to square of all the data, add all of them per 5 minus mean square equal to 1.34. Standard deviation equal to square root of 1.34 equals 1.1576. Then we find that the range 7 divided by 2 equals 3.5. Then in the total range 4.5 divided by 2 equals 2.25. Then the mean 4.2 divided by 2 equals 2.1. Hence the variance 5.36 divided by 2 square equals 1.34. And standard deviation 2.3152 divided by 2 equals 1.1576. So when each value of the set of data is divided by the constant k, New range equal to original range per k. New interquartile range equals original interquartile range per k. New standard deviation equals original standard deviation per k. And lastly, the new variance equals original variance per k squared. Is divided by the constant k equals is multiplied by the constant 1 per k. What are the effects on the measure of dispersion when an outlier is added or removed from the set of data? A. Range. The range will change dramatically when an outlier is added or removed from the set of data. B. Interquartile range. The interquartile range is less affected when an outlier is added or removed from the set of data. C. Variance and standard deviation. The variance and standard deviation will increase significantly when an outlier is added into the set of data. If the difference between the new value of the data and the mean is small, then the new standard deviation will be smaller and vice versa. If the difference between the value that is removed and the mean is small, then the new standard deviation will be larger and vice versa. C will be proved in example 13. Is a set of data, and the values here is equal to this. Okay, median is 39.5 and so on. 7.5 equals 39.5 minus 32, and 5.5 equals 39.5 minus 34. If we add an outlier, let's say 100, the range changes from 16 to 68. So the range will change dramatically when outlier is added or removed from the set of data. And then we see the variance and standard deviation. The variance and standard deviation increase significantly when outlier is added into the set of data. It increased a lot. The original mean is 39.5. If we add a new data where the difference between the new data and mean is small, let's say 39. So the variance becomes smaller and standard deviation also becomes smaller. If we remove a data where the difference between the removed data and the mean is small, for example, if we remove 39, the variance and standard deviation increase. It means if the difference between the value that is removed and the mean is small, then the new standard deviation will be larger and vice versa. How do you determine the effect of data changes on dispersion based on graphical representation? The effect of data changes can be graphically displayed by using dot plot, standard leaf plot, or box plot. A. The data is changed uniformly so by adding or subtracting a constant. Let's see this dot plot. Score in sign quiz. When each value of the set of data is added by 2, the dot plot becomes like this. In the diagram, when each value of a set of data is added by 2, it is found that the whole dot plot is shifted to the right by 2 units, where the dispersion remains unchanged. It shifts 2 units. The original score range equals 15 minus 8 equals 7, and the new score range equals 17 minus 10 equals 7. So the range of both sets of data is the same. When each value of the set of data is added by a constant, the measure of dispersion remains unchanged. B. The data is changed uniformly by multiplying or dividing by a constant. Let's see this dot plot score in mathematics quiz. When each value of the set of data is multiplied by 2, the dot plot becomes like this. In the diagram, when each value of a set of data is multiplied by 2, it is found that the dispersion of the whole dot plot becomes twice as wide. Original score range equals 5 minus 1 equals 4, and the new score range equals 10 minus 2 equals 8. The range of the new set of data is 2 times the range of the original set of data. When each value of a set of data is multiplied by a constant k, the new range equals k multiplied by original range. In general, when each value of a set of data is multiplied by a constant k, the measures of dispersion will change. C. The value added or removed is an outlier. For example, this dot plot score in mathematics quiz. When an outlier 9 is added, the dot plot becomes like this. In the diagram, when an outlier is added to a set of data, it is found that the dispersion of the whole dot plot becomes wider. This is wider than this. The original range equals to 5 minus 1 equals 4. New score range equals 9 minus 1 equals 8. The range of the new set of data becomes larger compared to the range of the original set of data when an outlier is added. The measures of dispersion of the new set of data becomes larger compared to the measure of dispersion of the original set of data when an outlier is added. Example 13. Given a set of data 4, 6, 7, 7, 9, 11, 12, calculate the standard deviation of the set of data. Hence, calculate the new standard deviation when A. 4 is removed, B. 7 is added, and C. 18 is added. The mean of the set of data is average of the data equals 8.5. Standard deviation of the data equal to square root of variance. So the variance equals square all the data, add all of them per total number of data minus mean square. Square root of variance equal to standard deviation equals 2.784. A. 4 is removed, and the mean becomes 9.143. Standard deviation becomes 2.356. When the value that has a greater difference from mean is removed, the new standard deviation will be smaller. The value that has a greater difference from mean is removed. Standard deviation will be smaller. The value that is removed is 4. The mean is 8.5. The difference is 4.5. So 4.5 means a greater difference. It says the new standard deviation will be smaller. Let's see. Original standard deviation is 2.784. The new standard deviation is 2.356. It clearly becomes smaller. B. 7 is added. So the means become 8.333. And the standard deviation becomes 2.668. When the value that is close to the mean is added, the new standard deviation will be smaller. This is the value that is close to the mean. The value that is added is 7. The mean is 8.5. And so 8.5 minus 7 is equal to 1.5. so 1.5 means close to the mean. So the standard deviation will be smaller. Original standard deviation 2.784, new standard deviation 2.668. It really becomes smaller. See, 18 is added, so the mean becomes 9.556, and standard deviation becomes 3.974. When the value has a greater difference from mean is added, the new standard deviation will be larger. The value has a greater difference. The value added is 18. The mean is 8.5. 18 minus 8.5 equal to 9.5. 9.5 means a greater difference from mean, so the new standard deviation will be larger. So the original standard deviation is 2.784 and the new standard deviation is 3.974, so the difference is greater.